In the last lesson, we saw how to use the sum and angle formulas, or sum and angle identities, if you will, to find the trig ratios of sums and differences of angles. In this lesson, we're using the double angle identities, which are on your reference sheet, and the half angle identities, which are not, sort of, and I'll get there. So in example 1, I'm trying to find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta, and I am given the cosine of theta. So if you look at the sine, cosine, and tangent double angle identities, in order to find the sine, I need to know the sine and cosine. In order to know the cosine, I need to know at least one of those. In order to find the tangent, I need to know the tangent of theta. So let's take what we know and find the sine and tangent of theta. We're told that cosine of theta is 3/5 on the interval 0 to pi over 2. So that means that the angle is in quadrant 1. So that means that the sine of theta and the tangent of theta are both going to be positive. So I can use Pythagorean's theorem to find the missing side length. Remember how we did that? If this is my theta and the cosine of theta is 3/5, then the adjacent side is 3, the hypotenuse is 5, and as I mentioned earlier, you can use Pythagorean's theorem to find the missing side length. It would end up being 4. So that means that the sine of theta is 4 over 5 and that the tangent of theta is 4 over 3. Now that I know those values, I can find the sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So the sine of 2 theta, the formula is right there on your screen as well as on your reference sheet. So the sine of 2 theta is equivalent to 2 sine theta cos theta. So that's 2 times 4/5 times 3/5. And we simplify this and get 24 over 25. That's the sine of 2 theta. The cosine of 2 theta is cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 sine squared. Dealer's choice. Pick one. I'm going to use the first one. So cosine squared of theta minus sine squared of theta. Okay, so the cosine was 3/5, so that's 9/25, minus the sine was 4/5, and when I square that, I get 16. And so the cosine is negative 7 over 25. Finally, the tangent of 2 theta is equivalent to 2 tan theta over 1 minus tan squared of theta. So we found that the tangent of theta was 4/3. So we have 2 times 4/3 over 1 minus that 4/3 squared. So that's 16 over 9. And so I've got a common denominator I need to get in the denominator, and I've got a fraction in my numerator. Let's take this step by step. In the numerator, I've got 8 over 3. In the denominator, I have that 1 being rewritten as 9 over 9 minus 16/9. So I have 8/3 divided by negative 7/9. But then I'm going to rewrite that division as multiplication and get 8/3 times negative 9/7 And when I simplify this, I have negative 24/7. In this example, we're solving an equation using a double angle identity. So on the left side of the equation, I have cosine of 2 theta. On the right side, I have negative sine squared. I'm going to rewrite that cosine of 2 theta as 1 minus 2 sine squared of, this isn't a theta, it's an alpha. Alpha equal to negative sine squared of alpha. And now I'm just going to solve it algebraically. I'll add 2 sine squared alpha to both sides and get 1 equals sine squared alpha. When I take the square root of both sides, I have that positive or negative 1 equals the sine of alpha. So on my unit circle, I'm looking for a y-coordinate of either positive or negative 1. So that's at pi over 2 or 3 pi over 2. For part B, I'm going to replace on the left-hand side that tangent of 2b with 2 tan beta, excuse me, not b, 2 tan beta over 1 minus tan squared beta, and that equals 2 tan beta. If I multiply both sides by 1 minus tangent squared of beta, that'll get rid of having a fraction. So I'll have 2 tan beta equal to 2 tan beta times 1 minus tangent squared of beta. If I bring everything over to one side of the equal sign so that I have a 0, I have 2 tan beta times 1 minus tan squared of beta minus 2 tan beta. And so now this 2 tan beta is a greatest common factor in this expression. So I can factor it out, and I would have 2 tan beta times, and this is going to get a little hairy, 1 minus tangent squared of beta minus 1. And then you probably realize, I really don't need those parentheses there. Well, the ones are going to cancel out. So I have 2 tan beta times negative tan squared beta. Well, that's just negative 3 tangent cubed of beta. And if I try to solve for the tangent of beta, I divide both sides by negative 3, and 0 divided by anything is 0, and I take the cubic root of both sides, and the cubic root of 0 is also 0, so 0 equals the tangent of beta. So I look at my reference sheet, I know that tangent is the ratio of y over x, so basically I'm looking for a y-coordinate that's 0 and an x-coordinate that isn't. So where do I see that? I see that at 0 or pi.